Imagine the entire universe concentrated into a point smaller than an atom. This tiny point contained all the matter and energy that would eventually become everything we see around us. Then, about 13.8 billion years ago, this tiny point exploded in a massive burst of energy. This explosion is what we call the Big Bang. The Big Bang wasn't an explosion in the traditional sense, like a bomb going off in space. Instead, it was the rapid expansion of space itself. Imagine a balloon with dots drawn on it. As you inflate the balloon, the dots move further apart, just like galaxies are moving away from each other in our expanding universe. In the first few fractions of a second after the Big Bang, the universe was incredibly hot and dense. It was so hot that matter as we know it couldn't exist. As the universe expanded, it cooled down, and the energy from the Big Bang began to transform into particles. The Big Bang is a mind-boggling concept, and it's hard to wrap our heads around the vastness of it all. But by studying the remnants of this ancient event, like the cosmic microwave background radiation, we're slowly piecing together the story of our universe's birth. As the universe cooled down in the first few minutes after the Big Bang, the energy that was once trapped began to transform into tiny particles. These particles are the building blocks of everything in the universe, from the smallest atoms to the largest stars. One of the first types of particles to form were quarks and gluons. Quarks are even smaller particles that combine to make up protons and neutrons, which are found in the nucleus of an atom. Gluons are the particles that hold quarks together. As the universe continued to cool, quarks combined to form protons and neutrons. These protons and neutrons would eventually come together to form the first atoms, mostly hydrogen and helium, the lightest elements in the universe. The formation of these fundamental particles marked a crucial step in the evolution of the universe. It set the stage for the creation of stars, galaxies, and eventually, planets like our own. Billions of years after the Big Bang, we can still detect faint echoes of this incredible event. This echo comes in the form of radiation known as the cosmic microwave background, or CMB. The CMB is like a baby picture of the universe. It's a faint glow of light that permeates all of space. This light was emitted just 380,000 years after the Big Bang, when the universe had cooled enough for atoms to form. Before atoms formed, the universe was a hot, dense soup of particles, and light couldn't travel very far without bumping into something. But once atoms formed, the universe became transparent, and light was free to travel through space. The CMB provides us with a snapshot of the universe when it was very young. By studying its patterns and variations, we can learn a great deal about the early universe and its evolution. Section 4. Stellar Nurseries, the birth of stars and galaxies. Over millions of years, gravity began to pull together the vast clouds of hydrogen and helium gas that filled the early universe. These clouds became denser and hotter over time, eventually reaching temperatures and pressures high enough to ignite nuclear fusion. This is the process where hydrogen atoms fuse together to form helium, releasing an enormous amount of energy in the process. This is how stars are born. As stars formed, they began to clump together into larger structures called galaxies. Galaxies are vast collections of stars, gas, dust, and dark matter held together by gravity. Our own galaxy, the Milky Way, is a spiral galaxy that contains billions of stars, including our own sun. The birth of stars and galaxies marked a turning point in the evolution of the universe. Stars became the factories where heavier elements like carbon, oxygen, and iron were forged in their cores. These elements are essential for life as we know it. Section 5. A cosmic cradle. The formation of our solar system. About 4.6 billion years ago, in a quiet corner of the Milky Way galaxy, a giant cloud of gas and dust, known as a solar nebula, began to collapse under its own gravity. As the cloud collapsed, it began to spin faster and faster, and the material in the center became incredibly hot and dense. This eventually ignited to become our sun. The remaining material in the nebula continued to swirl around the newborn sun. Over time, this material clumped together to form planets, moons, asteroids, and comets. This process of planet formation is thought to be relatively common throughout the universe. Earth, our home planet, formed in what's known as the habitable zone, the region around a star where conditions are just right for liquid water to exist on the surface of a planet. This is a crucial ingredient for life as we know it. Section 6. The pale blue dot. Life on Earth and beyond. Life arose on Earth about 3.5 billion years ago, first in the oceans and later on land. Over billions of years, life evolved and diversified, eventually leading to the incredible array of plants and animals we see today. Earth is the only place in the universe where we know for sure that life exists. However, the vastness of the cosmos suggests that we're probably not alone. Scientists are actively searching for signs of life on other planets, both within our solar system and beyond. The search for extraterrestrial life is one of the most profound scientific endeavors of our time. If we were to find evidence of life elsewhere, it would fundamentally change our understanding of our place in the universe. Section 7, Mysteries of the Cosmos, Unanswered Questions and Future Explorations. While we've learned a great deal about the universe and its origins, many mysteries remain. We still don't fully understand what dark matter and dark energy are, even though they make up the vast majority of the universe. We're also still searching for a unified theory that can explain all the fundamental forces of nature. The study of the universe is an ongoing process of discovery. New telescopes and space missions are constantly revealing new wonders and challenging our current understanding of the cosmos. As we continue to explore the universe, we can expect to make even more astonishing discoveries that will deepen our appreciation for the vastness and complexity of the cosmos. The universe is a place of endless wonder and mystery. By studying its origins and evolution, we gain a deeper understanding of our place in the grand scheme of things. As we continue to explore the cosmos, we can look forward to even more incredible discoveries that will illuminate the secrets of the universe.